Again, welcome to ITS 836. In this course, we are going to start with classification algorithm. So first, we're going to start with the basic concept. Then in our next lectures, we continue with some of the advanced algorithm in classification. So in these lectures, we're just going to discuss about the concept of classification. And also we're going to talk about the decision tree algorithm. And then in our next lectures, we're going to discuss some few classification algorithms, such as support vector machine neural network. So again, let's start with our lectures today. Again, this is classification, the concept, the basic concept. So normally we say classification algorithm is called also a supervised learning. In machine learning, we normally use the term supervised learning. So the concept of supervised learning means we have a training data set, and then this training data set will perform the role of supervision because this training data set consists of all the possible attributes. I'll use the term the independent variables. And also we know the dependent variables. So we know the target variable. So for example, if I want to build a model, a classification model for a system to diagnose, let's say, a disease A, what I will do is that I may have some amount of data set that consists of patients that have that disease A. So I know the patients, their characteristics or their attributes, and I know the outcome, which is disease A. So I'm going to use this data to build a model. And this data is called the training data because it has all the characteristics of a person that have a specific disease. And also we have the outcome of that specific disease. So a training data will consist of all the attributes and also the target variable, or the independent variables and also the dependent variable. So again, if it's a patient with disease A, then we have all the attributes of the patient and also the disease A. So in this case, we can have maybe any amount of patient, let's say 1,000, 10,000. And we're going to use the data set, apply the classification algorithm on it, and to build a model. After we build a model, we use something we call the test data set, the test data set. This data set, we have all the independent variable or the attributes, but it doesn't have the target variable or the dependent. So now it's up to the computer, the model, to predict. And as again, in classification, we have a method that we can use to evaluate our model, such as sensitivity tests and specificity, using the confusion matrix, measure the accuracy and precision of the model. We may go a little bit details on that. So we start with, again, supervised learning is the same as classification. So supervision means we have a training data, and this training data can be observations or measurements, and they are accompanied by labels. The labels will be the outcome, the dependent variable, indicating the class of the observation. So if we have a data set about patients that have obesity, then we may have the label as yes or no. You patient have the obesity, yes or no. Also, we may have a new data. It's classified based on the training set. Yeah. So again, this is classification. Then we have what we call the unsupervised learning, which is the clustering. And we use the term clustering algorithm. That is the difference between supervised and unsupervised, is that unsupervised learning, there's no training data set. So the main goal of a clustering algorithm is to find a similarity among the data sets and group them as one cluster. So some of the algorithm we normally use a measurement of distance to measure the similarities of the data. So here we say the class labels of training data is unknown. So we don't have, again, the training data set with the class label. So in cross-story, we are not going to build a model, but rather we're finding more or less like a data segmentation. We are finding similarities in the data set. So any values or any data set that have the same similarity, again, we group them as one cluster. Data set with the similarity, they don't have the same similar values, then we have to separate them. Yes, they have to go to different clusters, separate them. So here we say, given a set of measurements, observations, with the aim of establishing the existence of class or clusters in the data. So now we go to, again, our main topic today is classification. So we start with the definition. Here they say, given a collection of records, that's a training set. Again, a training set is a data set that have all the set of attributes, and at least one of the attributes is the class or the target label, the outcome. So if we have this training set, we are going to use this training set with the classification algorithm to build a model. So we find a model for the class attribute as a function of the values of other attributes. Now, our main goal is that we want to previously unseen record should be assigned a class as accurate as possible. So if we have a patient, we don't know if the patient have that disease. So this, based on the attributes of the patients, the algorithm can assign the class to the patient, whether he have the disease or he doesn't have the disease, or if the cancer is a malignant or benign cancer. So first, when we build a model, now we use a test set. A test set, as we said earlier, is a data set or the values, but doesn't have the class or the target variable. So a test set is used to determine the accuracy of the model. Usually the given data set is divided into training and a test set. With training set used to build the model, then the test set is used to validate it. Because training set have the class label, what we are looking for, whether patient have cancer or not. But the test set doesn't give us the class label. So now it's up to the computer to make that decision. And that's why it's called a test set, to test the model, to see how accurate the system is or how validates it. So this is an example here of classification task. So first we have a training set. So we can see that this training set is for taxpayers. So we have for example, we know the name of the taxpayers will not determine whether our class here is whether we cheat or not, whether the taxpayer cheat on his tax, yes or no. So we can see that we don't have the name because name cannot determine whether we cheat on tax or not. But we have a tax ID. The goal of the tax ID to uniquely identify each record. So we know that the attribute 1, 2, and 3 most likely they will determine the class, whether we cheat or not. So first attribute 1 will be, are we married, yes or no? Second can be our income, etc. So here we are assuming that we have a tax ID. Attribute 1, 2, and 3 will determine the class level, whether we cheat or no. So if we didn't cheat, it's no. If we cheat, it's yes. So this is a training set. Now we are going to use this training set with the learning algorithm to build our model. So after we build our model finish, we are going to use the test. So we can see that the test set, there's nothing on the class. There's no class label. So the test set now, we are going to use, actually that's why again it's called a test set. We are going to use, so again, to determine the accuracy of the model or to validate the model. So classification concept is 2 steps. The first step, we use the training set to build a model. Then the second step, we use the test set to validate or test the model accuracy. So these are some of the examples of classification tasks. For example, it has been used for predicting tumor cells as benign or malignant, whether the cancer is cancerous or non-cancerous, and dangerous or not dangerous. We also use it to classify credit card transactions as legitimate or fraudulent. Anytime we purchase an item using our credit card, and we have some rejection, maybe based on the profiling. Example, I live in New York City. For the past 10 years, I use my credit card only in New York City. I don't spend more than $1,000 in any transaction. All of a sudden, I end up in Texas, and I'm using my credit card to buy an item over $10,000. So this means I deviate from the profiling of my usage. So anytime we use our credit card, again, the system, in this case, machine learning system, it will again build our profile. So anytime we deviate from our profile, it will alert us. So, and also sometimes when we apply for credit card and it is denied, most likely it's a machine learning application that denies it. Also, we can use the classification to classify secondary structure of protein. You know, that we have a protein, have a primary structure of a protein is the sequence of the protein, the letters of the protein. The secondary structure normally is what we are looking at like an image structure. So it can be alpha helix, beta sheet, or random coil. So again, we can use the goal of, again, be able to predict a protein structure. Protein structure sometimes can tell us the function of the protein, We can also use the classification algorithm to categorize a new stories such as finance, weather, entertainment, sports, etc. And actually, this concept also applies to cross-story algorithm. So there are different types of classification techniques. We have the decision tree-based method. That's what we're going to cover today. In our next lectures, we're going to cover the rule-based method, memory-based reasoning, and neural networks, naive-based, and Bayesian belief network. That's the use, and the concept here use the probability, conditional probability concept. Then also support vector machines. So these are some of the, again, classification techniques. So prediction problem. Here we say, are we going to use classification or numeric prediction? Now, when we are doing supervised learning, classification means we are trying to predict a discrete or nominal data, such as yes, no, true, false, etc. Now, when we want to predict a numeric value, such as the price of a stock or employees' income in 10 years, these are values. We cannot use something like a decision tree is normally predict. Again, it's called classification because the class label most likely will be either nominal, discrete. So for example, neural network or even regression algorithm normally predicts numeric values or quantitative values. So here we say classification will predict categorical class label. So such as yes, no, true, false. So it will be discrete or nominal. And also it classifies data that constructs a model based on the training set and also the values, which is the class labels, in classifying attribute and use it in classifying new data. Now, with the numeric prediction, the model's continuous value functions. So this will predict unknown or missing values. The typical application, as we said earlier, can be credit or loan approval, medical diagnosis, if a tumor is cancerous or benign, fraud detection, if a transaction is fraudulent, and also web page categorization, which category it is. So we also said earlier that classification is a two-step process. First, we build a model, so model construction. In this case, we have to use the training set to build a model. So here we said model construction describing a set of predetermined classes. Each tuple or sample is assumed to belong to a predefined class as determined by the class label attribute. Tuple or sample also can be observations. We can use the term observations also. Here we say the set of tuples used for model construction is called a training set. Training set. Again, the reason why it's called training set because we have the attribute and also we have the class label. Also, the model is represented as classification rules or decision rules or mathematical formula. Mathematical formula can be neural networking, support vector machine. This use the functions or regression analysis also functions. Also, the model usage is for classifying future or unknown objects. We always need to, again, during the classification process, we need to estimate the accuracy of the model. It's very rare to have a model that is 100% accurate. But we don't want 50% or 60% accurate. At least somewhere between 80 to 90, 95, that is good. So accuracy rate is the percentage of test sample that are correctly classified by the model. So accuracy is the percentage of the sample that are correctly classified by the model. So example, if I have, let's say we have 10 records, and we're trying to classify, we build a model and we are doing classification. If we were able to be 8 correctly classified out of the 10, it means we have 80% accuracy. 80% accuracy. Also, the test set is an independent of training set. Otherwise, it will be overfitting. Overfitting means you have a training set and you use it to build a model. And the model was able to give you a very perfect generation, very perfect model. The model will build. But now, when we use the test set, we don't even come close to the best accuracy. Let's say we don't even come close to 60% or 70%, which means we build a model which looks very perfect, but when we test it, the model cannot work well, cannot do a good prediction, and the accuracy is not good. So if accuracy is acceptable, then we use the model to classify new data. Now, if the test set is used to select models, then we call it validation test set. So this is another example again, which again is the same concept as our previous example, 2 steps. We have a data set of professors in a specific school. We know the number of years they are serving, working in the school, and if they are tenured or not. So our class level is to know if this professor is tenured based on number of years they work. The training data set here we have saying that a professor have 3 years experience, but it's not years tenured. But another professor, after 2 years, it was 7 was 6 no, 3 no, another 3 no. So this is our training data. We're also going to use the classification algorithm to build a model or the classifier. So we need a training model. We need to train our model with our data set to, again, build it. So after that, then we use the test set. That's the second step. Use the test set to test it. So we have the model build. We use the test data on the classifier to see the accuracy of the model. So we start with the decision tree now. So at least we have the main concept of what is a classification. So a classification is a supervised learning algorithm. It's a two-step method. With classification, we need a training data. Training data is a data that also have the class level to build a model. After we build a model with the learning algorithm, we use another data called the test set. In this case, the test set doesn't have the class level. The computer or the model have to predict it for us. So it's two-step. Train the model, then you will test it. Now we will start with the algorithm. The first algorithm we're going to cover here is the decision tree induction. So we can see an example of a decision tree. The age here is called the root of the tree. We know in computer science, a tree normally the root is at the top and the leaf is down. In the real world, the leaf is at the top and the root is down. So here, yes node here is a root node. And the last down, no yes, these are called the leaves. So a leaf normally have only parents but no children. Root doesn't have no parents but they have children. Then the inner nodes may have both parents and children. So credit rating node have a parent that is age, and also you have two children of newer years here. So in this case, we start with building our model, which is our decision tree. So we check with their age. If your age is greater than 40, then we have our credit rating. Then the credit rating, based on the value, if the credit rating is fair, then we say yes. We're going to buy the computer. The decision tree is trying to buy a computer. And we are saying that buying a computer may depend on your age, your income, whether you are a student or not, and also your credit rating, since you are going to buy the computer with credit card. So in decision tree, we have a special techniques that we use to select our attributes. And we will discuss about that. For example, we have the concept of Jenny index, information gain, actually charge square, which is one of the techniques in statistics. We can use those techniques to select the correct or most common node for the attribute. So here we say a training set to buy computers. The data set follow an example of Quinlan's ID3 algorithm. So this algorithm, we are using ID3, the resulting tree. So based on this data set, this is the tree that was generated to us. If your age is less than or equal to 30 and you're a student, then you're going to buy the computer. But if you are not a student, you will not buy the computer. So sometimes we can generate a rule from a decision tree. So my rule here will be that if age is less than or equal to 30 and student, you're a student, then you buy the, so it's if then rules, then you buy the computer. Or if student is no, then you don't buy the computer. And the same thing was okay, if age is between 31 to 40, that one we're 100% sure you buy the computer. So yes. Now, if you are older than 40, then it will depend on your credit rating. Your credit rating is excellent, then you don't buy the computer. If your credit rate is fair, then maybe you buy the computer. So decision tree has so many algorithms. For example, we have the Hans algorithm. This is one of the common one, and that's the one we are going to cover here. We also have the CAT, ID3C4.5, Slink, and also Sprint. Slink and Sprint are normally used for larger decision trees. So this is the general structure of Hans algorithm. The algorithm said the first step, we should let DT be the set of training records that each reach and node T. So DT is a set of training records that reach and node T. Now, general procedure here. If DT, which is the database with the records, if DT contains records that belongs to the same class YT, so if all the records belongs to the same class, then we have a leave node labeled as YT because it belongs to YT, everything. So that's the first step. If the DT contains records that belongs to the same class YT, then T is a leave node labeled as YT. Now, if the DT is an empty set, which means we don't have anything inside DT, then T is the leave node labeled by default class YD. And now, if the DT contains records that belongs to more than one class, this is where we have to use our attribute test to split the data into smaller subsets. And that's what we did in our previous decision tree. Then recursively apply the procedure to each subset, which means we have to start all over. So again, this is the Hans algorithm for decision tree building. If all the data belongs to one class, then we have T as a leaf. And also if the data set is empty, there's no any value, which is the second step, then we assign leaf to the node. Otherwise, if it belongs to more than one class, then we have to use our attribute test concept to make sure we select the right attribute. So with Hans algorithm, we check with the refund, yes or no. Yeah, we say don't cheat, don't cheat. So if you don't cheat, we have refund again, don't cheat, or you marry marital status. So if you are single and divorced, you cheat. If you are married, you don't cheat. And the list keep going here. We have again married status. If you're single or divorced, you have a taxable income. If your taxable income is less than 80, then you don't teach. That's 80,000. If it's greater than or equal to 80,000, then you're going to cheat. So the tree induction, we have the grading strategy. The concept of grading strategy means we should split the record based on attribute tests that will optimize certain criteria. The issues with this is that we need to determine how to split the records, which is how to specify the attribute test condition and also how to determine the best split. And also determine when to stop the splitting. So how to specify the attribute test condition? Here we have the algorithm for basic tree induction. So A basic algorithm will be the grading algorithm. The tree is constructed in a top-down recursive divide and conquer manner. So at start, all the training examples are at the root. Then the attributes are categorical. With continuous value, then they are discretized in advance. What we mean is that, for example, if we have an age attribute and the age is 10, 11, 20, 15, it's a numerical. What we have to do, we can discretize it. So discretize means I have the age from 1 to 10, so that's okay. If your age fall between 1 to 3, enter 1. If it's between 3 to 6, enter 2. If it's 6 to 9, enter 3. So here we are discretizing our age attribute. So with the decision tree, discretization is very important because we said earlier we cannot use quantitative data. So every examples are partitioned recursively based on selected attributes. Also, the test attributes are selected on the basis of heuristic or start measure. Example will be the information gain. So what are the conditions for stopping the partitioning? So we say that if all the samples for a given node belong to the same class, then we stop. Or there are no remaining attributes for further partitioning, which is majority voting, will be employed to classify the leaf. Or there are no samples left. So here, computing information gain for continuous value attributes. And here we say if A, let A be the continuous value attribute, we must determine the best fit point for A. So we sort the value A in increasing order. Typically, the midpoint between each pair of the adjacent values is considered as a possible split point. So it will be AI plus 1 divided by 2. Will be the midpoint between the values of AI and AI plus 1. Now, the point with the minimum expected information requirement for A is selected as the split point for A. Now, D1 is the set of tuples in D satisfy A is less than or equal to the split point. D2 is the set of tuples in D satisfy that A is greater than split point. So we have 3 measures in general which return good result for the attribute selection measurement. First, we can use the information gain. It's one of the common method. Here it says bias towards multi-value attributes or gain ratio. Gain ratio normally tend to prefer unbalanced split in which one partition is much smaller than the others. Then one of the common one is the Gini index. Gini index normally is based on multi-value attributes, and also it has a difficult when number of classes is large. Then we have other attribute selection measures. These normally are used for a large scaling decision tree algorithm such as CHAD. CHAD normally is based on chi-square statistics, chi-square test concept. So here we say measure based on chi-square test for independency. Then we have the CSEP, which perform better than info gain and Gini index in certain cases. Then we have the G statistic as a close. It has a close approximation to chi-square distribution. Then we have the minimal description length principles, which is called MDL. This is the simplest solution if preferred. What happened, the best tree as the one that requires fewest number of bits to both encode the tree and also encode the exception to the tree. So we talk about overfitting and tree pruning. Overfitting is when you have a model that works very good for the training, and then when you apply tests, it doesn't work good. So here we say overfitting is an induced tree may overfit the training data. Too many branches, some will reflect the anomalies due to the noise and other outliers. Also, the poor accuracy for seen samples. And the two approaches to avoid overfitting will be pre-pruning. So pre-pruning means we're trying to stop the decision tree to grow larger in earlier stages. Then post-pruning means after we constructed our tree. So two approaches to avoid overfitting is pre-pruning, which is halt the construction earlier. Do not split a model if this will use the goodness measure falling below a threshold. This is difficult to choose an appropriate threshold. Then post-pruning means removing the branches from a fully grown tree. You get a sequence of progressively pruned trees. So these are the enhancements to the basic decision tree induction. We allow for continuous value attributes by discretizing the data. So in order to use age, then I will discretize in saying that from 1 to 5 is 1, 6 to 10 is 2, etc. So allow for continuous value attribute, but dynamically define new discrete value. The new discrete value attribute that partition the continuous attribute value. Then also you can handle the missing values or missing attribute values. This will assign the most common value of the attribute and assign probability to each of the possible values. Also attribute construction, we're creating a new attribute based on existing ones that are sparsely represented. And this normally will reduce the fragmentation, repetition, and implication. So classification in a large data set or large database, we said earlier, classification is a classical problem extensively studied by statisticians and machine learning researchers. The scalability, we classify data sets with millions of examples and hundreds of attributes. And then why is decision tree induction popular? Easy to understand the output, interpretation of the output, and relative faster learning speed also. Also can use the SQL queries for accessing databases. Yeah, we can do comparable classification cross accuracy with other methods. So we have the rainforest algorithm that will build the AVC list. AVC stands for the attribute, value, and class level. So again, we're going to end the lectures here. In this lectures, again, we talk about the basic concept of, again, classification or supervised learning. And we start with the decision tree. We didn't go detail on the decision tree, but again, the goal here is just to understand the concept. So in our next lecture, we may go detail on decision tree, and we may do one more classification algorithm. So again, wish everybody the best. Thank you.